My name is Carlos Lucasius. I work for Oracle in the Java SE Embedded team. This is the standard safe harbor statement. So, zero to deploy. I'm going to assume that you are still fairly new to Java SE Embedded, and maybe also fairly new to running Java on embedded systems. So that's the red zero, of course, in this picture. And I'm going to try to get you to a point where you know, you will know all the steps to take to start with an embedded card, how to put Linux on it, and then how to put Java on it, and then to run your embedded application. And by the way, please feel free to interrupt at any time and ask questions. It's a BOF session after all. So the program agenda. So it's organized according to what would be the logical steps to get you up and running from point zero to the point where you are fully deployed and running Java C embedded on an embedded system. There's a wide variety of embedded systems, of course, and generally speaking, but the good news is that the preparation process for getting started, generally speaking, is mostly the same for these different systems. There's some little things to take into account where things are different. Okay, and then I'm going to also try to include a demo, and then after that we can have a discussion. But at any time during the session itself, you can also interrupt and ask questions. Please feel free to do so. So let me start with a quick introduction to Java SE Embedded. What is the motivation for it? The motivation for it is what you may have heard before during this conference, which is the Internet of Things, where there's lots of devices everywhere, lots of systems. They're all interacting. They're all network connected. So it's a whole ecosystem, and embedded devices play an increasingly important role in this ecosystem. These are typically devices at the edge, as they say, because they are like at the terminal ends in this hierarchy of systems. Oftentimes, producing massive amounts of data, but they can also serve as systems that run servers or maybe persist information. The key point here is that these embedded devices are extremely diverse. We have all kinds of processors, all kinds of operating systems, and luckily we have Java, because Java has the ability to run on all these different devices if we have a JVM for them, and then applications can just migrate and be totally portable across different embedded systems. So Java SE Embedded is really Java SE optimized for embedded use. That is really what it is. So Java SE Embedded is optimized for embedded use, but optimized for embedded use on typically high-end embedded devices. When you think of Java embedded in the let's say 5-6 years ago, you would think about probably Java ME, but we've seen an opportunity to move Java also to higher-end devices using Java SE, and we just basically optimized it in a way so that it would run optimally on high-end embedded devices. And some of the typical things we've done to accomplish that task is, memory optimizations. We have removed some of the optional components. Java SE has various optional components that are not needed as per the specification. They give value to, some developers, but for embedded use cases, typically these components are not always needed. So those are the types of components that we basically got rid of. There are also runtime optimizations where we optimize the bytecode interpreter. it has to understand a new instruction set because we built implementations for ARM for PowerPC. Until then, we had never done that. So that's where the optimizations come in, and also the JIT compilers, which also generate native code. Those have been also customized to be able to run an embedded system. And then there is an increasing focus on multi-core because speed has hit a plateau, and where throughput is important, at some point you have to actually introduce parallelism, which can be done through multi-core. Just to give you a quick introduction on some of the example devices, we have some of the typical use cases. Java SE Embedded is increasingly being deployed, as I said, in the high-end systems, things like, point of sales terminals, digital printers, smart metering, etc., etc. So these are some of the examples. So let's now move on to the several steps that need to be taken to actually get up and running with Java SE Embedded on an embedded system. Obviously, you will need first to obtain hardware. Fortunately, there is a wide variety of hardware, affordable embedded boards that can be obtained. I provided a link here to a website that mentions 39 Linux-friendly embedded boards and products. Some of the examples of the boards are the Raspberry Pi, Beagle board, Panda board, Gooseberry board. There is a whole list of them. You will find them in this resource that I provided. There's also embedded products where it's not the board, but it's the board plus the encasing, so to speak. And examples here are, Cotton Candy, the Q-Box, Plug computers. For example, Marvell created the design for a Plug computer. They themselves don't actually manufacture these systems, but they license the design to those who want to implement the design and come up with these Plug computers. An example is Global Scale with their Shiva plugs. So I'm going to be focusing mostly on the Raspberry Pi board for this presentation. A lot of what I'm going to be mentioning is very much applicable also to other boards, and it's just easier to just give an example through one board because there's obviously not sufficient time to cover several. I have an embedded board here, a Raspberry Pi board, which is the size of a credit card, as you can see, and I just started it up. And I have connected to it here an SD card, which has the operating system. I connected to it as well here a USB stick, which carries some of the software that I'm going to be showing. And then also I have here a USB dongle for a wireless keyboard and mouse. Oops, sorry. All right. Is this still on? Hello? Okay. I think we are on again. All right. So this is an example of the Raspberry Pi board, a detailed view. I just showed it to you, but here are the details. So it's essentially an ARM V6 processor that has that runs at 700 megahertz. The board has 256 megabytes in RAM, and the price is actually quite attractive. It's $35 plus shipping. There are two models. There is a Model A and a Model B. B is the latest one that is currently shipping, and that is also the one that I just showed you, and that is being shown here as well. So where can you get them? Well, there's various vendors. You could easily find those vendors if you Google for it. I can mention a few. There is, for example, Premiere for an Element 14. There is RS Components. There are many more. And what I heard is you can get them also on eBay. Although I'm not sure if that's going to be much better in terms of price. So here is a top view of the Raspberry Pi with some of the peripheral connections. There is an HDMI connection for high resolution digital quality TV. You can, connect your monitor to it and, get a just pure full HD TV quality display. There are 2 USB ports. There is an SD card slot that I just showed you. It has an I2C bus, and it runs at 3.5 watt at 5 volts through a mini USB. Okay, of course, first you need to download the system. So we have covered the hardware now, and now we're going to getting the OS on it. This is where you would typically start. There is a special website at raspberrypi.org, and you go to the download section, and there's several images that you can try. The one that I have installed on this board here is the Debian Wheezy, which is from August the 8th. You would need to copy this image after you download it to an SD card. It's a fairly simple process. And I provided here a link where you can get detailed instructions for that. And then it comes to interacting with the boards. As I said, you can connect an HDMI monitor and a USB keyboard and a USB mouse. And that is typically how many people would do it, I guess. This is, what we call a headful configuration, where you have a screen, you have a keyboard, and you have a mouse, and that is perfectly fine for a lot of people. Actually, one note I should make is that if you don't connect the keyboard and the mouse, the system won't get to a full boot. So you need to be aware of that. You can actually also use it as a headless system. If you connect a keyboard and a mouse to it. Or what I usually do is, I connect a wireless keyboard and mouse, meaning that you only, connect a wireless adapter in it. And at that point, the system already thinks there is a keyboard and a mouse, and you can just, it'll finish the booting, and you have essentially a, headless system, if that's the kind of use case you're pursuing. So the next steps are not that hard either. There are some, in the standard distro, if you download the image and you and you copy it to your SD card, you'll notice there are, a couple of card partitions which I have indicated here on the slide. There's a boot partition, Linux root file partition, Linux swap partition, and you might want to resize some of them, to suit your needs. And if you do that, a good tool for that would be gparted. So you could just run it with sudo gparted and make all the necessary changes, resizings of all these partitions. There is optional networking setup. I believe by default the system comes with DHCP. You could configure it to have static IP if that is what you prefer. But it would, amount to changing a couple of files, networking files. Another approach, this is what I usually do if I want a fairly constant IP address, is you could do, you could do a DHCP reservation, where essentially you map a DHCP address to the MAC address of the device. Now, how do you find out what the MAC address is? The MAC address is, you can, run ifconfig or a tool like that, and it will show you the MAC address. And then you program that MAC address in your router, and you make there in your router a DHCP reservation for this system. And then from then on, with DHCP, it'll have a constant IP address as if you have static, IP. So that covers that. Next step is downloading and installing Java SE Embedded. This is not hard either. Here's a downloads page from our product website. If you go there, you'll find several implementations. You'll find x86 implementations. You'll find PowerPC. You'll find ARM. Obviously, you'll want the ARM version, and the one that is supported for ARM v6 specifically. So, okay, and now time for a demo that I have set up. The demo has been put on this memory stick here. It is a proof of concept blood glucose level meter, and it tries to realistically show and collect blood glucose data. Essentially, all the software is there except for the real sensor, which would need to take a blood sample every now and then. That is the part that I simulate. There is a thread running, and there is a model behind it, and it basically does that. Basically, what I program is when the subject has meals, which is where the glucose will go up, and then at what points, this subject, which could be a patient, needs to take insulin to get the blood level, the glucose level down again. So that is the in a nutshell what this application does, and I'm going to try to show it, and I've set up okay. Now let's see if I can get my, this is the part that might be a bit harder. Okay, so this black window is where I'm talking to the Raspberry Pi, and I'm going to connect to it. I think I've set up the connections correctly. There is here's my router for private network. One cable connected to my laptop, one cable connected to the Raspberry Pi, and I'm going to see if I can SSH into the system. It looks like it, and I'm going to say this is. I'm not sure, maybe I mistyped the password. Okay, so I'll try again. Oh, something has gone wrong with this application, I guess. Okay, let me try something else. strange. Oh well, I guess this was working before. Yeah, but we had changed it actually. So that is, yeah, I changed it to root and something else. But yeah, that is a good point. Let me see here. I'll try one last thing here. What's that? Yeah. Okay, let me try something here. Yeah. Oh. Oh well, in any case, this was working just a few hours ago. I'm not sure. The first step, okay, sure. Oh, okay, I guess I'm in, all right. I'm not sure why it must have been timing out and something. I'm not sure what, because normally it would go in right away. All right, so we're in. Let's see, CD, demo. Okay. So what I'm going to do now is I'm going to actually run this glucose meter. And I'm going to do that as follows. There's a couple of startup scripts here. I have startup scripts for different devices, so I'll have to just pick the one for this Raspberry Pi. Oh, sorry, there's something I need to do. There's a little setup required first that I kind of overlooked. Okay. This will set up the environment for all ARM systems. And now I'm going to here, and I'm going to run the meter right now. So, well, Okay. So what it does is it starts an RMI server. You can interact with this meter through RMI. And this is a simple server. For example, you could use it to pool data, glucose level data that have been captured by the meter and that have been stored in the database. For this database, we use a Berkeley database. And so this is just running right now. In fact, I've run it a few times before, and I could, for example, look at the current last, let's say, 10 records in the database. So here are the last 10 records with glucose level indicated here, and also the access times to get this information from the database. And this database is on this memory stick. So everything is there: the Java application that runs the meter, as well as the database that is gathering. So this way you can actually extract information from the system across the network. To run the meter, there's a help prompt here that gives you all the commands that you can provide to this meter. And let's see if we can connect now to this meter across the network. And I'm going to go now here. Is this visible? Oh, I think it's off the screen a little bit here. Let me erase it a bit. Okay. All right, the environment has been set up for him, and then let's see which one we're going to run here. Dot. We're going to now run a simple GUI that will connect through RMI with this meter. And we're going to run for that this one. Let's go back to this guy here. As you can see, it has now added a diagnostic message saying GUI window connected. So basically, whenever a connection is made, it does a bit of logging here, which is what this message is. And this is a simple GUI that you can use to extract information and make it show it visually. So let's see if we can get a couple of data. So this is currently the last 24 entries in this Berkeley database. And another thing I can do is actually to animate it a little bit. But to do that, I need to get the meter running. So I'm going to supply here the command R, which is running. And now the meter is running. And if we go back here now, if all goes well, you'll see actually the GUI being updated as a new data point is added all the time, which is currently set to 4 seconds, which of course is not realistic in a real scenario, but for the purpose of a demo, this is perfectly fine, I guess. I changed it just now to 2, so it should be a little faster now. Okay, so that's that. So I showed that I can remotely connect to this glucose meter. There's some other interesting things I can do with it as well. Let's close the GUI now, and let's see where I am. Oh, it switches space all the time. I'm not sure where my window is. Okay, it should be here. All right, so here's the meter. The other thing I wanted to do is to show that you can also extract diagnostic information from this meter, because Java exposes JVM interfaces, several of them. One is, for example, for management and monitoring. Another one is for you know, what we call the tools interface, JVM TI. And this is useful for example, attaching a profiler, and then you can collect information, which could be useful. And what I'm going to show is to attach what I have enabled here in this script is management and monitoring, and so I'm going to see if I can connect to it with the management and monitoring interface and see if I can, you know, extract useful information. So to that end, I'm going to try to connect to it. It's obviously a remote connection that I have, so I click this one. The machine name, the remote machine name is called Pi1, and I've set it up to communicate with port 9999. So, and we are going to connect here. And as you can see, this is you know, a simple GUI that shows all kinds of activities in the VM. This tool is called JConsole. It's available in every JDK, and it allows a remote connection to any other system that runs Java, and in this case Java on an embedded device. And you can see all kinds of interesting information, like for example the heap memory usage, how that changes over time. Let me make the meter run. Oh, it's in fact already running. Okay. Here you can see the number of threads, classes that are loaded, CPU usage. There's several tabs here. You can get a VM summary, what is your VM, etc. So yeah, with that, I hope to have given you a brief overview of you know, what you can do with embedded devices, how to get Java on them. It's fairly simple actually. You know, you can apply a wide variety of applications. You can do troubleshooting, things like that. So with that, if there's any further questions. Going once, going twice. Well, thank you very much for your time.